Hello everyone. In this particular video, I'll be covering certain fundamentals of set theory once again. In first video, I talked about some introduction to the set theory. In this video, I'll be talking about certain other things about set theory. These videos, 3 to 4 videos, are very important because set theory plays an important role when it comes to understanding of the probability theory. So in this particular video, we will be covering about cardinal number of a set, a singleton set, null set or void set, finite and finite sets, equal and equivalent sets. This will be covered in the next video, and we are going to cover this much that is actually that comes under types of sets. So this is the basic idea today to cover this entire stuff here. What is the cardinal number set? What is a singleton set? What is a null or void set? What are finite and infinite sets? Well, let's talk about the cardinal number of sets. The definition itself suggests the number of elements or members of a set is known as a cardinal number. So, elements or members, they're more one or same thing. So, if I look into this particular example, cardinal number of a set A, which has A, E, I, O, U, which are the vowels of English alphabet. There are 5 members in it, 1, 2, 3, 4, 5, or you can say there are 5 elements in it. So the cardinal number of A is 5. There is no formal way as such that how the cardinal number of means is supposed to be written, but you can simply write it like this, that cardinal number of A is equal to 5, because there are 5 elements in this particular set. If you want to represent this particular set in a Venn diagram, then this is a universal set, this is set A, and that is actually A, E, I, O, U. This is set A. So this is explanation on the cardinal number of a set. Now comes the next type of set, which is also called as a singleton set. So the set having one member or only one element in it, it is known as a singleton set. Or alternatively, you can say the set whose cardinal number is 1 is known as a singleton set. So the thing missing here is singleton set. And there are certain examples associated with it. If you see first example, there is only one member in this set, which is 1, so it is a singleton set. If you see second example, A is equal to X, such that is a lady president of India. You can also write it is and or was a lady president of India. So we understand there is only one single lady president which was there in India, Pratibha Devi Singh Patil. So that becomes again singleton set, because in this set A there is only one member, Dr. Pratibha Devi Singh Patil. That is only one element in this set. That's why it becomes a singleton set. X such that X is a prime number less than 3. So if I see how the members of this set can be listed, 2 is the only prime number which is less than 2, less than 3. So how many elements are there? How many members are in this set? 1. So the cardinal number here is also 1. So cardinal number of A is 1 here. Cardinal number of A is 1 here. And here also the cardinal number of A is 1. So therefore all these 3 are the examples of singleton set. Next, let's talk about the null set or void set. The set having no member at all. That means there is no member present in the particular set. Then that particular set will be known as the null set or void set, and at times it is also called as an empty set. It is represented by a Greek letter phi, or simply by 2 curly brackets, nothing in between. So phi can be written like this. Now do not get confused here in this particular example. This, if you see this the example here, the cardinal number of A is not 0. Cardinal number of A is actually 1, because 0 is one element in this particular set. So this is actually a singleton set. This is a singleton set because there is one member in this set and that member is 0. Another example, X such that X is a lady president of USA. So far there was no lady president in USA, so there is no element in it, and this becomes a null set, can also be represented by 5. X is a prime number less than 2. 2 is the least prime number, so there is no element in this particular set, and this can also be called as 5. So these are the examples of null set or void set. Let's talk about finite and infinite sets. The definition is very simple. A set having a finite cardinal number is known as finite, otherwise infinite. For example, if I see this set, the cardinal number of this set is 4 because there are 4 members in it. So cardinal number is 4, so it is called as a finite set. If I see this X such that X is a star in the sky, so people know that there are countless stars in the sky. It means we only know the number of stars which we have discovered. So the cardinal number is infinite and it will be called as a infinite set. Important equal and equivalent sets. So the equal set is when the two sets have same members, they are known as equal sets in whatever order. That means order doesn't matter. And however, if two sets have same cardinal number but the different members, they are known as equivalent. Right. So if I look into set number A, it has 4 members, 2, 4, 6, 8. So cardinal number of A is 4. If I look into set B, 6, 4, 8, 2. So cardinal number of B is also 4. But if you see, their members are also same. 2 is here, 2 is here, 4 is here, 4 is here, 6 is here, 6 is here, 8 is here, 8 is here. Doesn't matter in what order. So I can simply write A is equal to B. Now the important concept here is, if you want to write it mathematically, if X belongs to A implies X belongs to B, this says A is equal to B. This condition holds for all X. That means all members of A are also a member of B, then A is equal to B. Now on the other hand, if you see set A here, X is a vowel in English alphabet. So I know that A has these many members, A, E, I, O, U. And B is X such that X is a natural number less than 6. So B is going to have how many members? 1, 2, 3, 4, 5. Now if you see in both the cases, cardinal number of A is 5. Cardinal number of B is also 5. But this condition is not true. That means X belongs to A does not imply that X belongs to B for all X. That means the elements are not same. Therefore, these are called as equivalent set and will be written as something like this. A is equivalent to B. The notation changes. So what we can say is, you think about it, every equal set is also equivalent. It is equivalent. Let me correct it. Equivalent. But the converse is not true. Think about this statement and you can easily find it justifiable. So this is exactly what I wanted to cover in this particular video so far, equal and equivalent sets. And thank you very much. The next video will be covering about subsets of a set.